Hello everyone, I'm Alfian and today we are going to solve the Hackerrank challenge for the algorithm preparation and then the implementation section called the number line jumps, or in other words the Kangaroo problem. And then we are tasked to solve two kangaroos jumping at different velocities, and then we need to find if they are going to meet halfway in one on the same jump in one moment. And then we have to figure out a way to get both kangaroos at the same location at the same time. If it's possible, then we are returning the string, since we are using the TypeScript, and we are explicitly returning the string which is yes string, or if they are not going to meet halfway, then we are going to return the no. But at first we may want to check for which kangaroo has the bigger velocity than the other one, or checking if they finally meet and see if either will surpass the other. Then the iteration will stop if we are using the while loop, but that will be impractical. And also for the third possibility, which is using for loop, is doable to safeguard the infinite loop, but how many jumps or loops they need to take to find their meeting point? What if they are already past one another and yet the for loop is still running? That would take some time, and also that would bloat the big O notation. And then after I look up on some solutions, I finally figured out using the algebra instead of using the while or for loop. So for example, like this, if the first kangaroo combined with their velocity and then times n, the n is the number of jumps required in order for them to find each other at the same point at the same time. And then for the second kangaroo, that is added with their velocity, or the second kangaroo velocity, and then times n, which is the jumps required to make them find one another. And then for the second process, we can move the first kangaroo velocities times n, and then minus the velocity number 2 times n, and then equals the x2, which is the kangaroo number 2, and then minus x1. Why is it minus? Because x1 is moving from the first equal and then moving to the back, and then it will be the opposite equation. And then for the third process, we can simplify the velocity 1 minus the velocity 2, and then times n, and then equals the first kangaroo minus the second kangaroo position. And then for the final part, we can find the number of jumps required for them to meet at the same point at the same time. So we are calculating the position of Kangaroo 2, and then with minus the position of Kangaroo number 1, and then divided by the velocity of the Kangaroo 1 minus the velocity of the Kangaroo number 2. And then without further ado, and we also need to consider several things, which is they both need to have different velocities. Let's say if they have the same velocities, then they are going at the same paces, and that would look, or we are not going to find their meeting point. So that is why we need different velocities between each of Kangaroo. And then for the second one, let me think for a moment. The number of jumps value, or the end value, needs to be an integer. Yes, because they jump from one to another integer. So for example, the first Kangaroo will be added by the first velocity, or the first Kangaroo's velocity, and the sample input is integer, and there is no floating point at all. So that is why we need to find the meeting point, which is the integer value. And also since they are jumping from left to the right, which is always the positive number, they are moving to the right side, leading to the positive infinity, like the above description. And then their meeting point is either at the spot or more to the positive side. Hence, we need to prevent the negative result. Yes, if we get the negative integer, but that only happens when they both move to the left instead of the right. So that is why we need to find the positive number. And then also for the final check, if they are starting from, or starting at the same spot, then the riddle is already completed even before we starting this solving the question. So without further ado, let's do this by checking the velocity of the first Kangaroo using the parenthesis is not equal to the second velocity, or the second Kangaroo's velocity, and also using the AND statement, compare the second Kangaroo position, and then minus the first Kangaroo position, and then we are using the modulo operator, and then dividing it by 1, or the first Kangaroo's velocity with the second Kangaroo's velocity, and then to check if it's equal 0, and also adding the another AND clause, which is the second Kangaroo position minus the first Kangaroo's position, and then divided by the first Kangaroo's velocity minus the second Kangaroo's velocity, to check if it's higher than or equal to 0. If so, then we can return yes. just like that. And then for the force check that we already declared using the else if both position already at the same, then we are also returning yes. And then for the second or the final check, else return no, which means if they have the same basis, and if they have the floating number meeting point, and if they are on the minus meeting point. And this if else clause alone already covered most of the edge cases. And then let's run the code to see if it works. Okay, so that's about it. I hope you have a great day, and I hope you understand my explanation. If you have any questions, if you have any other better solutions, you can write in the comment section, and I will happily answer each of them. I hope you have a great day, and I will see you on the next video. Goodbye.